So what's happening here is in cycloidal teeth, a cycloid is a curve traced by a point on the circumference of a circle which rolls without slipping on a fixed straight line. So what do you understand? So this is the pitch line. So below pitch line here you will be having the base circle. So this will be the flank part and that will be the face part. Right, so it is defined as a curve traced by a point on the circumference of the circle. So it rolls without slipping. So when it rolls without slipping, it helps in forming of an cycloidal profile. So this will be the actual movement. So next it will be traced to another part. So that is what been told. So if the circle rolls without slipping on the outside of the pitch circle, it is called as an epicyclic. If it rotates on the outside the pitch circle, and if it rotates inside the pitch circle, it is called to be as an hypocycloid. So the rotation of the circle without slipping on the base circle is called to be as your cycloidal profile. So if it is above the pitch circle, it is called as epicycloid, and if it is below the pitch line, then it is called as hypocycloid. So this is the difference between the epicycloid and the hypocycloid. And next is involute profile. So this involute profile was designed by Leonhard Euler. Okay, so how do you define an involute profile? It is defined as a locus of a point on a straight line which rolls around the cylinder without slipping. So it is a locus of the point what we trace out. So how do you trace out the locus of a point? You have to understand the involute form and the profile. It is there in your syllabus. Okay, I think it is there in your form also when you do the design. So now consider this as a base circle. So if this as a base circle, so you can consider the point A as a starting point of your involute. So this base circle can be divided into n number of parts, right? So each part you can name it as this is a starting point from A to P1, right? The second part will be from P1 to P2. The third part will be from P2 to P3. Similarly, you can divide the entire circle. So after dividing the circle, so you have each segments here on the base circle drawn, right? So then the tangents at each point are now drawn from P1, from P2, from P3, etc. So how you draw with respect to what measurements? It are drawn with respect to the length of P1 and A1. So this is P1. Okay, when where is A1, so this distance you will measure. So after dividing that into different distance, so this distance what we have from A to P1, the same distance will be extended and drawn here as a tangent. And similarly, to draw the tangent over here, you will measure the distance from AP2. The arc AP2 distance will be measured and the same distance will be drawn as a tangent over here. Similarly, for the third segment here, you will measure the distance from A to P3 and same distance will be drawn as a tangent over here. Okay, similarly this will be done for the entire circle. After doing it, it will end at some common point here. So when you trace out the path, the profile what you get is termed to be as our involute profile. So in involute profile, after getting the involute profile, anywhere you join the line, that will provide you the tangent, and this line segment will provide you as an normal. So this is about the involute teeth profile. How does it look? And you, if they ask you to how do you measure the involute teeth profile, so that also we will be taking care next. So this is about the involute tooth profile and the cycloidal profile. In cycloidal we have two, one is epicycloid and hypocycloid, whereas in involute profile you have only one involute profile with respect to the base circle. How it is rotating, you will get the required aspects of the segment as well as the normal part. So when you trace out this, you will get the required involute profile. And also the tangent, yeah, the tangent A3 T to the involute is perpendicular to P3 A3. So this tangent what we are getting will be perpendicular to A3 and P3, and this acts as a normal to that of the tangent. So in any a point what you find out, so it will be always normal. Okay, this line will be always normal to that of the tangent what you trace out, and the normal line what you draw will be with respect to the base circle. So how, what will be the distance of this also I have told you. So each normal what we are joining here will be equal to the segmental distance from a P3 will be equal to this distance, A P2 will be equal to this distance, A P1R distance will be equal to A1 to P1. Where it meets, you will just trace out in the free hand and you get the involute profile. Yeah, similarly you can construct and construction of a cycloidal gear tooth. So in this what happens is, I told you know the same thing here, the cycloidal profile. Okay, the cycloidal teeth of the gear can be constructed as shown here. So this is the circle C is rolled. This circle C is rolled above the pitch circle without slipping. So if it is rolled above the pitch circle, you will get the epicycloid, and if it is circled below the pitch, you will get the hypocycloid. So if they ask you how it has been constructed, you can show this path. Okay, so here the circle D. This was for the circle C for epicycloid. For the hypocycloid, you have to show the circle D is rolled inside the pitch circle so that you get the hypocycloid PB, and here you get the epicycloid PA. Okay, so this is PA and this is PB. So, and you have to show the direction in which it has been rotating. So this profile BPA is one side of the cycloidal tooth. Remember that it is just showing you the one side of the cycloidal tooth. The opposite side of the tooth is traced out in this dotted lines. Okay, so you can show the both the ways of the cycloidal tooth profile with respect to the pitch circle, and show for epicycloid and the hypocycloid. If they ask you to explain the gear tooth profile related to cycloidal and with respect to cycloidal as well as involute, you can show both. And then comes the advantages of the cycloidal, and then how do you inspect the involute form. So involute form I'll take it in the next class, and advantages also I will take it in the next class. So please hold on, I need to take the screenshot of the attendance. If there were around 41 students, now I can just see 36. Anyone who is not there? Everyone, have you entered your names in the chat room? Hello, kindly speak up.
Yes, ma'am.
Anyone who
Yes, ma'am.
haven't? See, be serious. If you find any difficulty in understanding, please ask in between or message me or mail me. I am uploading the same, but kindly do adjust. There is some problem related to the net facility. It is getting interrupted in between. I'm seeing how best that could be overdone. If anyone haven't written your USN number, kindly type it up. I'm selecting all together. So we are now left out with just the last part of a third module, how to inspect the involute form and the run out of the gear we have to deal with. So after doing that, your third module completes, and remaining questions related to 3.1, that is a gear, 3.2, that is a gear measurements, I will be sending you all. And there are numericals related to the gear measurements actually, but in 18 scheme it is not mentioned. So currently I'm not solving any problems because it is not there in the syllabus. If it was there in the syllabus, you have to use the gear data handbook, the formula, and substitute and calculate the measurements. So that part is currently not there in the syllabus. So I'll be covering the entire theoretical part with respect to the derivations. So if they ask you in the examination, kindly derive with the neat sketches and show its advantages and limitations as well. So you can speak up if you have any doubts. Okay then, thank you everyone. You can speak out if you have anything, or else I will stop for the day.